Hello everyone, welcome to Science Friday.
Here's some for E as well. The one on the top here is one of the ways that you can define E.
What makes a field more likely to have an unbalanced gender distribution?
So this can be like, in the case of this paper, gyrification or brain folds.
A neuroscientist started to look at the brain
computers, like the
more as an
very
incredibly negative
aspects.
Yep, as she said, feel free to challenge me with a question throughout. Also, if you don't understand something, make sure that you speak up as soon as possible because the argument will cascade and build on itself, and it's extremely cumulative. So if you're not sure of something at some point, make sure, oh, do I need to speak louder?
Yeah, do you want louder?
Oh, no, but do I need to speak louder? Okay. Oh. So, yeah, interrupt me with questions throughout if you don't understand something or just want to challenge the argument itself. So the story is going to start with, contrary to the guidance and wishes of college counseling, with an AP Music Theory textbook, which I was reading over the summer just to study for the test, also contrary to the wishes of college counseling. And I noticed that all of the excerpts, literally all of them, so not every single one, came from a European male composer from either the 18th or 17th or 18th century, depending on how years work. I can't be bothered to count right now. But every excerpt came from a white male European composer in that time period in what is referred to as the Common Practice period, which is colloquially known as the classical music period. Common Practice refers to about 1750 to 1920. Now, I was wondering if there had been any sort of data statistical-based analysis to see whether these excerpts actually were systematically coming from a European or non-European source. And it turns out that Philip Ewell, who's a music theory professor, has done an extensive analysis of music theory textbooks and where specifically they're finding their excerpts. So specifically, if we look at the percentage of examples, and the examples here are musical excerpts just to demonstrate a particular musical concept, the percent of these books that together control 96% of market share, the percentage of musical excerpts that they are using from non-white authors across all of them is less than 3%. In Aldwell and Schachter's case, it's literally 0%, meaning that every one of their examples came from a white composer. And cumulatively, out of 96% of the market share, 1.67%, that's 49 out of 2,930 opportunities to illustrate a non-white composer end up with an actual non-white example. And to just see how disproportionate that is, out of the about 8 billion humans on Earth, only approximately 1 billion, less than that actually, live in Europe. And of course, here we're really talking about Western and Northern Europe. And if we consider the literal countries, this is probably around 80 or 90% of the examples coming specifically from France, Germany, or Italy in a world of 8 billion people. So if we don't understand why there's this clear lack of representation, then music theory as an academic discipline is, one, inherently weakened, and two, immediately loses its appeal to be the universal language. So that's an extremely common saying, that music has this power to transcend cultural boundaries and show people their common humanity. But if we're taking our definitions of common humanity from something that is going to misrepresent 98.33% of the population, then it's pretty clear that music theory as an academic discipline and music as a concept utterly fails to actually transcend any of those cultural boundaries that it would claim to. And obviously, if we don't understand why this is the case, then music theory academia will continue to have this peculiar problem, and that will continue forever, generally. So, moreover, we might ask the question how we actually got to this point. And for that, we'll need to understand a bit of the background of music theory, but this is just the bare minimum required to understand the actual argument here. So we're going to start with this model of music and all sound as a difference in air pressure. Now, keep in mind that the actual waves that are going to be propagating through the air are longitudinal. That is, they're like a way a slinky compresses. Here we have a transverse wave that represents the pressure. So if you think about the pressure that is right outside your eardrum, or the way that your eardrum is going to be moving in response to pressure changes in the air, we can consider the pitch to be analogous to the wavelength of the pressure wave itself. So the distance between crests or troughs, or the length of a single period, is going to correspond to the pitch, with higher pitches meaning higher frequencies and lower wavelengths, so that's to the right of the piano, and lower pitches referring to longer wavelengths to the left of the piano. Now, while we're mostly going to focus on pitch as a consequence of this physical model, this model is actually quite versatile and can be applied to a lot of other musical concepts. For example, the pulse can be likened to a beat, and the envelope of the sound can be likened to articulation, though we won't spend much time on those. Now, second, we can think about maybe layering these sound waves together. Now, in general, to humans, actually, musical notes sound consonant together. That is, they don't sound dissonant. They don't interfere with each other particularly when we're talking in a harmonic sense, if the ratios of their frequencies and wavelengths are in simple integer ratios. So canonical examples for those are 2 to 1 being a perfect octave, and that's to such a degree that a 2 to 1 ratio is considered to be the same note. When you go from A, for example, an octave up, you hit another A, and we consider those to be the same note. The second most simple ratio, that would be a 3 to 2, is that of a perfect fifth. And then 4 to 3 and 5 to 4 are ones that look nicer as graphs, so that's why I've chosen them, but they correspond to a perfect fourth and the major third. Now the major third, the perfect fourth, the fifth, and the octave, together that gives us 4 of the 7 notes of the major scale. And the others are also quite simple ratios. Now at this point, if you know the difference between equal temperament and just intonated systems, then you need to calm down, because to get into that would open a can of worms. Now the second big concept is that of a cadence. Now a cadence ends a musical phrase in the same way that a punctuation mark forms the end of a sentence. Now, these cadences can be categorized based on the harmonic relationships of the notes making up the cadence. So that's going back to the ratios of wavelengths and frequencies. The cadences in the notes that make up their wavelengths and frequencies, that's going to determine what kind of punctuation mark, so to speak, we have at the end of our sentence. Now, the first one that we're going to involve is the perfect cadence, which is considered to be a descending bass line, 5-1. So that's a 3 to 2 ratio between the lowest notes, and that is referred to as a perfect cadence. Now, actually, we'll cover that later. But a second example would be that of the Aeolian cadence, which is also known as the propaganda cadence, based on how many times it's been used in the Star-Spangled Banner at the end, and that has its origin in Whitney Houston's rendition. But the Aeolian or propaganda cadence has a flat 7-1 relationship. So that's slightly more complicated of a ratio. It isn't as immediately harmonically pleasing, but still this gradual ascending flat 6, flat 7-1 is not dissonant in any way. It's certainly a very consonant way to end a musical sentence. Now, the perfect is extremely common in the common practice period, which, as I said, is the technical term for what we might think of as classical music in a more layman sense. Now, the common practice period holds up the perfect cadence to be the gold standard, the exclamation point, if you will, at the end of a sentence. And this has been a practice or a theoretical conception that dates back at least 300 years, possibly even before that, to Gregorian chants and choral music, when we didn't actually have a strong record of music theory. In contrast, the Aeolian cadence is much more common nowadays in jazz and rock. And if we trace back its history, it developed through, obviously, jazz in the early 1900s, and before that, in the blues tradition. And if we go back even further than that, we can find evidence of the Aeolian cadence in West African tribal harmonies. Now, what that means is we have two distinctly different systems of theoretical organization, because the Aeolian cadence is by far more common in jazz and rock than a standard, what's called a perfect authentic cadence in jazz and rock. And likewise, in classical music, the common practice period, the perfect cadence is a lot more common than the Aeolian cadence. So these are entirely different systems of harmonic organization that just sort themselves into different cultures, because certain cultures have decided to value one cadence over another. Yes. Now, the way that we analyze cadences, these Roman numerals in the top, are derived based off of a system known as figured bass. Now, figured bass is an extremely archaic system. It originated to analyze compositions like Dixit Dominus by Handel and other choral music. The point of figured bass is to literally track the relationships of notes in the melody to that of the harmony, and to also indicate what kinds of chords are being used at each stage. Now, in the figured bass system, the perfect cadence is seen as the gold standard, as I was saying, because this was developed originally to analyze European choral music, where the tradition of the gold standard of the perfect cadence, the exclamation point, really became set in stone. Now, this is an extremely archaic system, and if we tried to analyze a lot of modern music, even contemporary classical music, figured bass would break down as a mode of representation. So we might naturally ask the question, why is figured bass still used? Because in music theory textbooks, if you look through them, figured bass is still ubiquitous as a method of harmonic analysis. And what these authors justify in their teacher's notes or pedagogical philosophies is that figured bass is used for two reasons. One, for indicating chord inversions, and two, for representing intervals and melodic motion above a bass line. Now, those are both extremely general concepts, but taken together, chord inversions and melodic motion above a bass line forms the basis of what started as tonal counterpoint, a specific way of analyzing choral music, and what was developed in the late 19th and early 20th century to the tenets of Schnekerian analysis. Now, Schnekerian analysis is the reason why many music theory textbooks currently value figured bass so much. It's because it's seen as the baseline for this mode of analysis, Schnekerian analysis, that was developed by Heinrich Schenker, who was an Austrian music theorist in the early 20th century over the body of his corpus, I guess. Now, we can actually recognize some of the classic markers of figured bass here and here. So in the top, we have 3-2-1. This was one of Schenker's own innovations that I'll cover in just a bit. He would liken entire sections of music and sort of perform whatever mental gymnastics he needed to in order to get the music to fall into this 3-2-1 pattern, and I'll explain why later. And second, at the bottom, we can see that 5-1 in the bass, and that is, again, going back to that 3-2 ratio of frequencies, that ascending perfect fifth, and that is what classical music has generally considered to be the gold standard in the common practice period. Now, Schenker combined these two concepts of a 3-2-1 melody and 5-1 harmony, again going back to the tenets of figured bass, with relating the harmonic motion and melodic motion to chord inversions. And he called that the fundamental structure, which is roughly translated from the German Ursatz. Now, I will struggle for a few seconds to exit the slideshow and play an example. It is occurring to me that that might not be worth it, but now, for obvious reasons, Schnekerian analysis is often denigrated for reducing all systems of musical organization into three blind mice, because effectively that is what Schenker was doing. And Schenker had a very liberal interpretation of when music could be construed to be as fitting the Ursatz. So, as I said, he would perform all sorts of mental gymnastics to get to his necessary conclusion. For example, over 20 bars, several minutes of music, Schenker might say that it really possessed the character of the third degree of the scale or the second degree of the scale, just so he could get his musical compositions to fit into the structure. So in no way was Schenker actually performing some rigorous analysis. He was really just trying to get everything to fit his own bias, and Schenkerian analysis, and specifically the Ursatz, might be seen as one of the greatest examples of confirmation bias in academic history. Now, this 3-2-1 Ursatz, Schenker labeled it, or not Schenker, but Schenker's proteges have labeled it the fundamental structure when they brought his ideas from Austria and Germany to the United States, where Schenkerian analysis has really been built up over the last century. Now, the specific use of the term fundamental should be somewhat alarming because it indicates that this very specific structure, if you really think about it, 3-2-1 and a 1-6-4-5-1 in the bass, which is a quite complicated system of organization that you wouldn't immediately label as general and fundamental. Schenker's protege's use of fundamental is clearly something to be thought about a little more deeply because it indicates that, maybe something about the way that European composers had been writing music for the last 150 years when Schenker was developing his theories was actually fundamental. Now, not to close read Schenker too much, but if we see what he was actually saying, our geniuses mastered the tonal materials and they were drawing up these motivations from a mysterious fundamental source. And just one more thing that I didn't bold, but this term of free fantasy. Schenker had decided when he was developing his theories that all the great composers of Europe were drawing up their ideas from something that he called free composition in resistance to the stronger, the more rigorous, more rigid rules of tonal counterpoint that people like Tchaikovsky had been developing. Schenker thought that the great European male composers were taking some deep eternal truths about the universe and extrapolating them in order to make great music, culminating in what he saw as the fundamental structure, the Ursatz. Now, again, not to close read, but his use of R in Our Geniuses, I think, is quite telling for obvious reasons. Now, yeah, this is from a work that he published about 15 years into his development called, 15 years into the development of Schenkerian analysis called The Art of Improvisation. And again, improvisation is certainly an odd choice of words given that Schenker was sort of implying that all great musical works were based on his Ursatz, his fundamental structure. So now we might think, how does this translate to our modern understanding of music? Sure, this is Heinrich Schenker's views on music, but this is 100 years ago in Austria. How could this possibly translate to that American market share of music theory textbooks in the modern day? And another thing that we might consider is maybe, you know what, maybe Schenker is right. I think he knows something we don't about the strength of the Ursatz, the strength of the perfect cadence, and why it would be so much better than any other form of musical structure. Now, to test this kind of thinking, a study was done where people of varying musical backgrounds, this is both classical conservatory students, jazz conservatory students, and members of the general population, and they were engaged in a paired t-test to compare the strength of harmonic resolution in the perfect and Aeolian cadences. Perfect is that 5-1, which is seen as the gold standard in classical music, and the Aeolian or propaganda cadence is the flat 7-1. Now, each study participant listened to both a classical sample without the cadence and a jazz sample without the cadence, and then, or a rock sample, I believe, in this study. And then they listened to the actual cadence, the perfect or Aeolian, and rated how satisfying, how finalized, how resolved the different samples actually sounded to them, based on what kind of style they had been primed to think in. And then to control for, oh, yes.
I just want to make sure I understand. So the study was basically they listened to the style of music without the ending.
Yes.
And then just the
Yes. So they were primed to think in a certain musical paradigm, either classical or rock, and then they heard one of two cadences, and then they self-reported the degree of resolution or satisfaction that they felt, that they experienced for those particular cadences. Does that answer your question?
Yeah, so it's like I'm in rock mode, now I
Yep.
hear this ending, how do I feel about it?
Yeah, that's exactly it. And a large point is that this is from a diverse population. So it's not just people who have spent 4 years studying classical music or 4 years studying jazz. This is a general population, a representative sample. So the results from experiment 1. What we're really looking for here is the gap in how resolved a classical versus rock setting sounded when either using the perfect or Aeolian cadence. So the dark gray corresponds to the self-reported score of harmonic resolution in an Aeolian cadence, and the light gray corresponds to the self-reported score of satisfaction with the perfect cadence, and those were played across classical and rock. So that's all the information in the graph. Now to interpret it, we're really looking at the gap between the perfect and Aeolian across both classical and rock settings. Now I think it's pretty obvious to see that the perfect cadence was quite overvalued compared to the Aeolian cadence in a classical setting, but that advantage essentially vanished when looking at the rock cadences and comparing the perfect Aeolian cadences. Now, don't fear, the p-values were well below 0.05 in this case, so they could conclude that the perfect cadence and Aeolian cadence did have significantly different harmonic resolution self-reported scores when used in either a classical or rock setting. Now, there is one complicating factor to that, and that is that the classical samples were all performed on piano and the rock samples on electric guitar, and we might think that that definitely affects our connotations of what cadences might be more or less satisfying based on the kinds of instruments that are being used to orchestrate our composition. So to control for that, they did another experiment, but this time playing everything in both timbres, both instruments, and again, looking at the gap, we can see that yes, while there is now a gap in the degree of resolution between the perfect and Aeolian cadences in rock music, it is still statistically significantly smaller than the gap in self-reported resolution between the perfect and Aeolian cadences when played in a classical setting. So to summarize all of that, even when controlling for timbre, switching styles of music significantly changes the degree to which the perfect cadence is seen as better, more finalized, more resolved than the Aeolian cadence. So this is really cutting to the heart of what Schenker was proposing with the Ursatz, that the reality of musical perception is more complicated than Schenker would have us believe, and that Schenckerian analysis shows. The Ursatz is not some fundamental truth about how humans perceive musical resolution. So just to go over what we've covered before making the final conclusion and tie-in to the original data, we first saw the inequality in musical examples and the excerpts that were being used in the current state of music theory academia. Second, we looked at cadences, specifically the perfect and Aeolian cadences, and saw that the perfect cadence has been used a lot more in the common practice period, whereas the Aeolian cadence has been used a lot more in rock and jazz. And now, we might also wonder why I'm specifically using the Aeolian cadence and why that study used the Aeolian cadence. It's because there's been a lot of development and music theory about and surrounding the Aeolian cadence in the United States, even though it does not come from a European source. So the Aeolian cadence has its primary origins in West Africa, but it has been analyzed a lot, and a lot of work has been done on looking at its impact on American jazz and rock. So if it were possible that a Carnatic or a Hindustani or a Chinese system of musical organization had also had the same level of devotion in the United States, maybe we could have had other cadences, but right now that sample size is just severely limited by the kind of work that American academia has put into these cadences, and obviously that's a result of the kinds of bias against those cadences that American academia has fought so hard to enshrine. Now, then we looked at figured bass and that system of organization that, though it is archaic, is extremely ubiquitous in the current state of education. And then we found that that is why Schnekerian analysis is why figured bass is so heavily taught, because Schnekerian analysis requires figured bass as this underpinning of its entire theoretical organization. And finally, we saw through that priming study and harmonic expectation that Schenker's proposition that the Ursatz, the fundamental structure, his assumption that really underlies all of his analysis, is fundamentally just not so fundamental. So now circling back, we can look at this data now in a new light, and we can reinterpret it to see that figured bass has been propped up to enshrine Schenkerian analysis as a method of analysis, and Schenkerian analysis unfairly values the perfect cadence over the Aeolian cadence, and certainly other cadences as well, though those exact studies have not been done. And now we can see that this is not actually as innocent as a misunderstanding as we might previously have thought. This is yet another example of confirmation bias. It started with Schenker, and it's continued in the last century in American music theory to just further enshrine Schenkerian analysis and the perfect cadence, which are fundamentally European concepts that value the achievements of white European men over all others. And that is pretty much, I think, the definition of a systemically, functionally racist system of theory. So does anyone have any questions? Sure. Oh, yeah.